All right, the question asks this. An investigator collects a sample of a radioactive isotope with an activity of 370,000 becquerels. 48 hours later, the activity is 120,000 becquerels. What is the half-life of the sample? Well, this is a relatively straightforward radioactive decay problem. The sample starts with this activity. 48 hours later, it's this activity. And we know that the activity decays with the following relationship. The activity at any time is equal to the initial activity times 1/2 to the power T over T 1/2, where T 1/2 is the half-life. And that's what we're looking for in this problem. So to prepare, let's get our numbers together. The initial activity is 370,000 becquerels. Okay, so that's this number. The final activity at the time of interest here is 120,000 becquerels. Okay, so that's our initial, that's our final, and the time for this to happen is 48 hours. That's how much time it takes for the change to occur, and we're looking for the half-life. Now, before we start, let's do a quick estimate. It starts out with 370,000, finishes with 120,000. A third of 370,000 is about 120,000, so it's decayed by about 1/3. Well, if it was one half-life is a decay by a half. 2 half-lives is a decay by a quarter. So I'm going to guess, since it's a third, it's between 1 and 2 half-lives. I think it's closer to 2 half-lives. So 48 hours is a bit more than 2 half-lives. I'm going to estimate about 30 hours. Because if this is the half-life, 2 half-lives is about 60 hours. That's a bit more than 48. 1 half-life is 30. That's a bit less than 48. So that seems about right to me. But let's do the solution. And to do the solution, we rearrange our basic equation to look like this. R over R0 is equal to 1/2 to the T over T 1/2. Then I'm going to take natural logarithm of both sides of the equation, and I end up with the following. The natural logarithm of R over R0 is equal to the T over T 1/2 times natural logarithm of 1/2. What I'm trying to solve for is T 1/2, and so T 1/2 is equal to the natural logarithm of R over R0 divided by the natural logarithm of 1/2 times the time. And we know all these numbers. The time is 48 hours, the initial activity is 370,000, the current activity is 120,000, and so we can put those numbers in and we calculate a half-life. If we do that and we round to 2 significant figures, which is appropriate given the statement of the problem, we end up with a time of 30 hours. And our assessment is this. That's exactly what we estimated it would be, given our approximation that the time, 48 hours, is a little bit less than 2 half-lives, and it's a little bit more than 1 half-life. And so everything works out.